Okay, so today we're going to be talking about the inverse trig functions. Okay, so sine, cosine, and tangent are functions. They also have their inverse function. Okay, um, the easiest way to understand the inverse functions and how they work for the trig functions is to actually go through the process of limiting the domain and range so that the function is one-to-one and coming up with the actual inverse function ourselves. So that's what we're going to do. Okay, so we're going to be using the key values of sine from negative 2 pi to 2 pi, and we're going to put them on this grid. So basically we're starting from almost the exact same place we did when we graphed sine. The only difference is the chart is horizontal this time instead of vertical. So we're going to start at 0, 0. And again, we're going to use values that are easily graphable. So for instance, I'm not going to use pi over 3 for sine because square root of 3 over 2, or pi over 4, which is root 2 over 2. But I can use very easily pi over 6 because their sine is 1/2. I can use pi over 2 because sine is 1. I can use 5 pi over 6, which is 1/2, and then pi 0. So I'm going to use the pi over 6 and the quadrantiles to actually come up with this chart. Okay? And I'm going to do it from 0 to 2 pi, but also from negative 2 pi to 0. And basically this side is just going to be the reflection of the other side. So at negative pi over 6, we're at negative 1/2. And at negative pi over 2, we're at negative 1. And at negative 5 pi over 6, we're at negative 1/2. Negative pi 0, negative 7 pi over 6, 1/2. Negative 3 pi over 2, 1. Negative 11 pi over 6, 1/2, and negative 2 pi 0. Okay, so here is our chart. So at this point, let's look at what we have going on. So what is the domain of y equals sine x right here? Okay, well, the domain are my x values. So technically, sine goes from negative infinity to positive infinity. But what we've graphed right here, our domain is from negative 2 pi to positive 2 pi. And our range is going to be from negative 1 to positive 1. Okay? So if we graph this, so it'll look like this. And that's what we expect to see. And we just see our parent function and one more period on the negative side. Okay? So this is the regular sine wave. Okay? Nothing new here. But now we're going to use this idea because if you remember when we did inverses, we talked about how a function has to be one-to-one in order for its inverse to be a function. One-to-one function means that it passes both the vertical line test and the horizontal line test. And the sine wave does not pass the horizontal line test, which means that its inverse will not be a function. So it's very similar to the quadratic and the square root function, where the quadratic is not one-to-one. The square root function, of course, is one-to-one. So, but we know that they're inverses. So what we're going to do here is we're going to actually restrict my domain to values that do not repeat values of y. So what I'm going to do, and I know that sounds weird, is I'm going to start writing down values from my chart Okay? And why didn't 1 show up? We're going to write down values from my chart here, and we're going to keep going until I repeat values of y. Okay? So that's what we're going to do. So right here, 0, 0. Then up at the chart I look, I've got pi over 6. Pi over 6 is 1/2. Then pi over 2, which is 1. And then the next one is 5 pi over 6, which is 1/2. But see how we've repeated that y? So we're not going to use that one. We're going to stop because we've repeated a value there. Okay? And we're going to do the same thing going the other way. So negative pi over 6, negative 1/2, negative pi over 2, negative 1, negative 5 pi over 6, negative 1/2. And see how that one repeats. So we're stopping right there. Okay? So basically what we've done is we've restricted our domain based on our y values so that nothing repeats. So the domain of my restricted sine, okay, is from negative pi over 2 to pi over 2. That is my restricted domain. And the range, though, is still going to be from negative 1 to positive 1. Okay? So basically what we've done is we've started our domain here and ended our domain here. We've basically cut everything out on the left side of that marker and the right side of that marker. We've kept only what's in between those two values. Okay? So now what we're going to do is we're going to use this table and we're going to create the points for the inverse function. And if you remember, to create an inverse, you switch x and y. Well, that means you also switch domain and range. So that's what we're going to do. We're going to take the table above and switch it. So now we got 0. This is going to be 1/2 pi over 6. This is going to be 1 pi over 2. This is going to be negative 1/2 negative pi over 6. And this is negative 1 negative pi over 2. Okay? So these are the coordinates, these are the points for my inverse sine function. Okay? Now notice that my new domain is from negative 1 to 1, and my new range is from negative pi over 2 to pi over 2. So, like we said, the inverse, we've switched the domain and the range, the x and the y. And we're going to do the same thing for the graph. We're going to graph on this graph here what the inverse sine function looks like. Okay? So my first point is negative 1, negative pi over 2, so right there. Then negative 1/2, negative pi over 6. So if this is pi over 2, pi over 6 is going to be like a third of that, which is going to be right here. It's going to be something like there. 0, 0, 1/2 pi over 6, which is going to be like right there. And positive 1 pi over 2, which is right there. And when you connect your dots, it looks like that. That is the inverse sine wave. And if you go back up here and look at this one, we had just said that when we restricted the domain, we're basically using this piece right here, right? Well, the reason I have it on both of these is if I put that piece down here on this one, you would see that it would look something like this. So this one reflects there. Look like this. That's the original sine where the purple is the inverse sine. And if you remember, when you talk about the inverse, the graphs, they reflect over the y equals x. The y equals x line is basically right here. Now, what does this mean? Okay? This means that in my original function of sine, I can plug in basically any x value, and my y values will only be between -1 and 1. In the inverse sine, you can only plug in values of -1 to 1, but you're only going to get values from -pi/2 to pi/2. Now, that means that if you think about it in its quadrants, the unit circle, from here to here, this is quadrant 1. And from here to here, this is quadrant 4. So basically, the inverse sine, you're only going to get values back from quadrant 1 or quadrant 4, and we'll talk more about that tomorrow. Okay? But knowing this domain and range for your inverse function is going to be really, really important. For instance, if you're in your calculator and you try to plug in a value that's bigger than 1 into the inverse sine value, inverse sine function, it will give you an error. But this also means that you have to be careful because your outputs aren't going to work correctly. Okay? For instance, you're never going to get back from the inverse sine function anything from quadrant 2 or from quadrant 3 on the unit circle. So you're going to be very, very careful in realizing that. Okay? That's the inverse sine function.